Okay, next is question number 19. So here the question says a deep sea diver is a person who swims at great depths below the surface of the sea. So part A is saying to help a deep sea diver move downwards quickly, spherical meshes are attached to the diver. During a dive, one mesh became unattached and fell to the bottom of the sea. So part A1, it's asking to state the conditions for Stokes law to apply. Okay, so for Stokes law to be applicable, we know that there are a lot of conditions, right? So for 2 marks, we will just consider 2 of the conditions. We can say at first, let me say all of the conditions. First condition is what? The object should be spherical. This is already they have said that the object is spherical, so we will ignore that. Then the object should be small. It should have a smaller radius. Second condition. Third condition is what? It should be slowly moving through the fluid. Okay, and at last, the fourth condition is that the flow of fluid around the body should be what? Laminar. Okay, so since the question has already mentioned this is spherical, so we will ignore that. We will consider any two from the rest three conditions. So we can say the object, the body, or the object, whatever you say, the body should be smaller, or should have smaller radius, should be smaller. Second one, we can say the flow of fluid around the body should be what? Around the body should be laminar. Should be laminar. That's enough. Fine. Okay. Next is part 2 of A. Okay, here the question says the mass accelerated to terminal velocity as it fell to the bottom of the sea. At terminal velocity, the mass fell 25 meter in a time of 0.36 second. Okay, there was a difference of 4.6 Newton between the weight of the mass and the upthrust on the mass. Okay, fine. The spherical mass has a volume of 45 centimeter cube. The volume of the sphere it's given. Deduce whether Stokes law applies as the mass fell through the water. Viscosity of water, it is given as 1.2 times 10 inverse 3 Pascal second. So this type of question is very much frequent in the recent past papers. So in this case, what we will consider? We will consider the resultant force, the forces acting on the body in when it is moving with terminal velocity. Okay, so at terminal velocity, we can write at v terminal, at terminal velocity, what's the condition? Weight is equals to what? Upthrust plus the drag force, right? Okay, drag force. So what we need to show here is that the difference between the weight and the upthrust it's given, right? So take upthrust to the left side. So W, that is okay, weight minus upthrust, it is equals to what? Drag force. Okay, weight minus upthrust, this difference is what? 4.6 Newton. So we got the drag force. Drag force is what? 6 pi r eta v. This is equals to 4.6 Newton. So from there, let's figure out the eta. Okay, and then we will compare it with the given one. Okay, we can do two things here. Either you can find out a value for eta by making eta the subject, or you can make v terminal velocity the subject and then compare it with the given one. Both way will work. Okay, so let's consider 4.6 over 6 pi. What's the radius of the sphere? The volume is given 45 centimeter cube. Okay, so 6 pi, we need to find out the value for eta. So 6 pi v, we need to find out the v also. So v equals to what? the time is given, distance traveled it's also given. S equals to Vt, so V equals to S over T, 0.36. So that much meter per second. So 25 over 0.36, that would give you 625 over 9 meter per second. Okay, 625 over 9 meter per second. Okay, so this is the value for V, and then we need what? The radius. So the spherical volume, it is what? 4 over 3 pi r cube, right? So 4 over 3 pi r cube, this is equals to how much? 45 centimeter cube. So 45 times what? Centimeter cube to meter cube, it will be 100 inverse 3, right? Centimeter to meter, it is divided by 100. So since it is cube, so 45 over 100 cube, which can be written as 45 times 100 inverse 3. So from there, figure out the radius. So 45 times 100 inverse 3 times 3 over 4. Okay, times 3 over 4 pi. Okay. Then you have to cube root the answer. Okay, if you cube root the answer, you will get the radius, which is, the radius is 0.022202206518788 meter. So 0.022 something. Okay, I'm not writing the exact value. Already I have given it here, so it is saved in the calculator. So now get the value for eta. Eta equals to how much? Answer times 625. I'm calculating the denominator at first. 620 answer times 625 over 9 times 6 times 3.1416. Okay, and in the numerator it is 4.6. Divide the answer. Okay, so this gives the value for eta. It is 0.15926 Pascal second. Okay, and the given value for eta, it is what? 1.2 times 10 inverse 3. This is basically 0.0012. 0.0012. So it doesn't match with the given one, which is not equal to what? 0.00 Pascal second. Okay, so we can say Hooke's law isn't applicable. Okay, hence Stokes, no, not the Hooke's law, sorry, Stokes law. Stokes law cannot be applied to the motion of the mass. That's it. Fine. So you can do the, you can make this deduction using both the ways. I have considered the viscosity here. You can consider the terminal velocity also. You can find out the terminal velocity and then compare with the given one. Both ways will work. Fine. That's all about part 2. Okay, next is part B. So here the question says the graph shows how the vertical velocity v of the diver varied during a dive. Okay, so this is the velocity time graph given. Okay, part 1 here, it says the diver was at the surface of the sea at 0 second. Explain how the graph could be used to show that the diver reached the surface of the sea again at 82 second. Okay, so how this graph shows that at 82 second the diver is on the sea water surface. Okay, how? So in this case we will consider the displacement. How we will consider the displacement? The area of velocity time graph, it gives what? Distance, right? So if this distance, if it is negative, then it will be what? Displacement, negative displacement. If it is positive, then it will be what? Positive displacement, right? So what we will say, area under velocity time graph represents what? Graph represents distance. If this distance is negative, then it will be what? Negative displacement. If this distance is positive, then it will give positive displacement. Okay. So if you consider the distance, from 0 to 25 seconds, it is what? Negative, right? And if you consider the distance from 35 seconds till 82, it is what? Positive. And both these distances are equal. So that means it is negative distance, this is what? Positive distance. So if you add them up, positive negative cancels out, so total displacement is what? 0. That's it. So what we will write here, area under velocity time graph from 0 to how much seconds? 25 seconds is equal, is what? Negative, and is equal to the what? Area under velocity time graph from 35 to 82 seconds. Hence, what we can say, at 82 second, what? Total displacement is 0 meter. Since the total displacement is 0 meter, so it means what? The diver has reached the water surface again. That's it. That's the answer for part B1. Fine. Okay, next is part B2. In part 2, the question is asking to determine the vertical acceleration of the diver at 70 seconds. Okay, so we need to find out the vertical acceleration. So we need to check out the velocity time graph, because the gradient of velocity time graph gives what? Acceleration. So to find out the vertical acceleration, what we need to do, we need to draw a tangent. Let's draw a tangent here at 70 seconds. This is the tangent. So you will use a scale to draw the tangent at 70 seconds exactly. Okay. This is the tangent at 70 seconds. Okay. Now take 2 points and find out the gradient. Let's say we are taking this point we can take. Okay. Let me show you clearly using dotted line. Let's take this point. Okay, this point. This is one. And another one we can consider the 70, this point. Okay, itself. The point 70 itself. Okay. There you go. Now find out the gradient. So gradient would be y2 minus y1. So what's that point? This point has y coordinate. X coordinate of this is 70 and its y coordinate, it's basically this. It's basically 0.2 222426. Okay, 0.2 to 0.4. That means each point is 0.05. So 0.25, 0.3. Okay, so there are how many? 3. Okay, 0.2 over 5. Okay, each small square is 0.04. Okay, so 0.24, 0.28, 0.32, and this is 0.36. Okay, so this is 0.36 minus 0.36 minus this y coordinate would be 0.56. 0.36 minus 0.56 over 0.7 minus 0. The x coordinate, it's basically not 0.7, 70 minus 50. Exactly, 70 minus 50, 70 minus 50. So that would give you a negative value, definitely 0.36 minus 0.56 over 20. So it is negative 0.01 meter per second. So negative 0.01 meter per second. So meter per second squared. Okay. So acceleration is negative 0.01 meter per second square. That's it. That's the answer for part B2 from question number 19 of October 2024 Physics Unit 1 paper. Fine.